Hello, everyone. This is Shauna, and I'm coming to you today with a video from section 4.5 on using the counting rules and the other rules that we've learned in chapter 4 to find probabilities. So let's get on with it here. I'm going to share my screen at this time. And what we see with the first problem, it says, find the probability of getting two face cards, a king, a queen, or a jack, when two cards are drawn from a deck without replacement. Find the probability of getting two face cards, a king, a queen, or a jack, when two face cards are drawn from a deck without replacement. So let me at this time do one other thing, which is, let me turn on the captions at this point. So here we are with this problem. Now, there's a couple of ways to do this problem. I've mentioned that before. I'm going to show you two ways in this video to do this. You can choose one. Either one will get you credit on the exam. So here's what we're looking at. If you remember from earlier in the chapter, and I'm sure you do, it hasn't been that long. When we started looking at probability, okay, we looked at it and we said this. We said that, I'm gonna get black here, said that the probability of an event is equal to the number of ways for that event to occur, the number of ways that you can actually have an event occur, divided by the number of outcomes in the sample space. Now, we're going to employ the same logic here that we have in the past chapters, okay? And we're going to use the sample space for a deck of cards, which we've used in the past. The difference here is that we're going to need to use either the counting rules or the rule for dependent events or combinations to help us, because the number of ways to get this event is way larger than we can comfortably count. And the number of ways to select two cards out of 52 is way too large. So remember, here our event is choose two face cards from a deck of 52, sorry, without replacement, okay, without replacement. And so that's my event. Now we're going to keep something in mind. I'm going to go back to the deck of cards here so you can see, okay? Here's my deck of 52 cards, okay? And these 12 on the end that you see with people on them, the four jacks, the four jacks, the four queens, the four kings, those are face cards, okay? There are 12 of those, 12 out of 52. The 52 is this whole deck. Now, once you choose one of these face cards, whatever it is, you're not going to put it back. So whatever you choose, there will then be one less card in the deck, which is 51, and there'll be one less face card because you want both of them to be face cards, okay? So one way to do this problem, here's the first method, okay? One way to do this problem is to say this. one way to do this problem is to say, okay, let's look at the probability that the first card is a face card. And the probability of the second card is a face card. Okay. So remember, these are not the same. Okay. So here, this is given, right? Because we've given the first is a face card as well. So we're looking at dependent events here. Okay. So we're looking at dependent events for this. So if you do it this way, then how many ways are there to get a face card the first time? Well, you know that there are 12 face cards in the deck. There's 12. And there's 52 cards total, right? 12 out of 52. But then the second card being a face card means that you're going to have, and we're not replacing, keep that in mind. So now, as I mentioned, there's 11 cards that are face cards left in the deck. And you're looking at the result from that, which would be 51. Okay, so one way to approach this problem is to multiply 12 out of 52 times 11 out of 51. Okay, now if I go and I look at this here, let me get the calculator at this time. So I'm going to grab the calculator here, clear my work out, and I'm going to have this. I'm going to have 12 out of 52. Oops. 52 times 11 out of 51. Okay. And that's going to equal 0.0497. That's my decimal. I'm going to change this to so I have 12 times 11. 12 times 11 is 132. And 52 times, 52 times 51 is going to be 2652. Okay. So I have if I wrote all four of these out, the four ways of doing it, I'd have the following. I'd have 132, this would equal 132 out of 2652. Okay. 2652. That would be my original. Then I'd have my reduced fraction. So I'd reduce this, and I think you all remember how to do that, but let me show you here. I'm going to go back to my calculator, and I'm going to do 132 out of 2652. And I'm going to go to this answer and go to convert math, convert to frac. And there it is, 11 out of 221. So we have this is 11 out of 221, right? So this is my original fraction, my reduced fraction. Then I have my decimal, which we've seen already. This is equal to 0 point, and if I want to make it 4 places, let me share the screen one more time. This is 0.0498 if I round it. If I go to, one thing you can do if you don't like rounding, you could set your float. So remember, we can go to mode here, go down to, go down to this, the second row where you have float, and set your decimal places on however many you like. If you want it on 4, which is usually customary in this chapter, we're going to set it on 4. Make sure you hit enter so that the background color changes and it will take it. Then quit from the screen and you can go back, get your fraction, and then you can say 11 out of 221, do the division and get that 0.0498. So here we have this part. This becomes this is, let me erase this part. Hold on, let me undo it. There. This is equal to this is equal to 0.0498, which is equal to, remember, to get from the decimal to the percent, I multiply by 100, so this will be 4.98%. And that's how that's one way to get my answer for this question. That's if you use, these are dependent events because the probabilities are different. Now, another way to do this is to use combinations, okay? Combinations without replacement work just like the way you would expect them to. So our standard combination formula that we use is for without replacement, okay? So if I go over here, let me use another whiteboard here. Okay, if I use another whiteboard, then I have, again, so we're looking at the probability of drawing 2 face cards without replacement from a standard deck of 52, okay? That's what we're looking at, essentially, right? So if I'm looking at the probability of my event, then I'm going to look at the number of ways. So I'm going to write this as the number of ways to draw 2 face cards. Now, this time I'm going to use the counting rule. So the number of ways to draw 2 face cards, okay? The number of ways to draw 2 face cards over the number of ways to draw 2 cards, period. Okay. This is the number of ways to draw 2 face cards, and this is the number of ways to draw 2 cards more generally, right? So if you recall, let's go back here. And if we're going to use the counting rules, then you have to make sure you're in the right group. So when I talk about the number of ways to draw 2 face cards, I'm not talking about, yes, I'm talking about the whole deck in terms of probability, but if I'm going to draw 2 face cards, then I have to draw 2 cards from these 12 that are face cards, right? So here, what I'm going to say is this. I'm going to say from, so this is from the 12 face cards, draw 2, okay? And at the bottom, I'm going to say from the 52 cards in the deck, from the 52 cards in the deck, draw 2. That's the difference, okay? That's what we're looking at here. So, because our sample space, remember, is the set of 52, all right? So I hope that part makes sense to you. Now, if I'm using combinations, then this becomes this. This becomes from 12, choose 2, right? From 12, choose 2. And then from 52, choose 2. Okay. And then it's time to get your calculator out and compare them. So 12, choose 2. Let's do this on the calculator. Okay. So we have 12. Remember, to get to your probability, you go math and you go to the last option, probability. And then number 3, NCR. 12, choose 2, 66. Okay. And then you have 52. We're going to repeat it. Math, probability, and CR 2. 1326. And so here we have 66 over 1326. And let me remind you that, let me remind you that here, when we did our calculation previously, so this becomes 66 over 1326. Now, 1326. Aren't you glad you didn't have to count all of those? But there they are, 66 out of 1326. So now, let me remind you here of something. When I go back, this is not the same fraction, but we didn't use the same numbers. But if you look back here, watch what happens here. So this is, if I reduce the fraction here, let's go to the calculator. We can say 66 out of 1326. And we get the same decimal. Now, what do we get for the fraction? Come up here and go math, convert to frac. Okay. This is a smaller, whoops. Apologies, folks. Let me delete this. Here we go. And let me come up here and go to math, convert to frac. There it is. So this is just a smaller multiple of the initial fraction that we got. So it would come out the same. The initial fraction is different, but the reduced fraction, the decimal, and the percentage will all match each other. Okay, so I hope that this has been informative for you. Hope that you understand the problem a little more. This is going to be 11 out of 221. Okay. And then you have the same technique that we had before. This is going to be 0.0498. And that becomes 4.98%. So this is going to be 4.98%. Okay, and that is it for this exercise. I hope that this video has helped you, and I'll see you in my next one. Thank you very much, everyone.